Want to welcome you guys to our second live online session this spring. And our focus today is going to be on research methods. So this is really the second segment of chapter 1 in your textbook. We actually don't finish it up until this coming Tuesday, which means you actually don't have any learning curve quizzes that you have to complete by this Sunday night. They're due a week from Sunday. So you've got more time to get up and running with that. If you're ready to start working on those and get those done, that would be great. I think it'll make your life a little bit easier if you start plugging along, getting those done at this point. So our advanced organizer here, our outline for research methods is as follows. We're going to talk about research designs. That's going to be pretty much our exclusive focus today. So how do you design the study that will help you answer your questions that you have about behavior and mental processes? If you're a research psychologist, you've got 3 main tools at your disposal in terms of these research designs. You could do a descriptive research design, you could do a correlational research design, or you could do an experimental research design. As we're going to talk about, the experimental design is going to be the very best one. And if and when you can do experiments, that's always the preferred choice. But it turns out that especially in psychology, there are going to be situations where it's unethical to study what you're curious about via an experimental design. We'll talk about that a little bit today. On Tuesday, when we get together, we'll finish up the final little segment on research designs, and then we'll launch into a discussion of measurement issues. And the 2 biggies there are going to be reliability and validity. We're going to introduce them here. And then we're going to talk about them again when we get into talking about intelligence, when we talk about personality assessment, when we talk about psychological disorders. Reliability and validity will come up at least 3 more times this semester after we introduce it here in part 1 of our course. On Tuesday, we'll also talk a little bit about data collection techniques, so different ways of gathering the information that will be part of your study. And we'll do a final segment on Tuesday in the last 5 or 10 minutes about statistics. Here's the deal. It's not going to be anything more complicated than what my youngest did 3 years ago when he was in 3rd grade. Means and medians and modes. We'll talk a little bit about standard deviation and range, but nothing incredibly complicated, and you won't need to really go and compute just about anything. So very, very simple look at statistics. But again, as I said, our focus this morning is going to be on these research designs. And what I'm going to do at the beginning here is something that I do about 3 or 4 times over the course of the semester, where I begin the class session by asking you a question about something that I'm going to teach you. And the idea is I do one of these pre-teaching questions, then I teach you something, and then I go back and re-ask that question. I don't actually tell you what the correct answer is the first time I ask the question. And generally what we hope happens is what? What we hope happens is that, are we having problems with sound? We hope that you learn more and know more after I ask it the second time. Can you guys hear me okay? If you can hear me okay, tell me in the chat box. Okay. All right. So somebody suggests to those folks maybe logging out and logging back in. I can't do troubleshooting while I'm trying to teach. So somebody just tell them in the chat box, maybe log out and log back in. Thanks, guys. Or turn on your audio. Okay. So let me give you this first little clicker question, not really a clicker question, but a polling question here in our online session. Thanks, Ryan. All right. All right, so Omar was having problems, but now is not. What I want you to do is chime into the chat box with your best guess at the answer to this question. It's a pre-teaching question. None of these are worth any points, but I want to see what you know on the front end here. A researcher measured the public's attitudes towards capital punishment via a telephone survey. What kind of research does that sound like? Descriptive, correlational, experimental, or uncontrolled? Just type in A, B, C, or D is fine. See a lot of A's and D's. I'm probably seeing more D's than anything else. Okay, so as I said, what I'm going to do is come back to this question probably 40 or 45 minutes from now, and we'll see if the pattern of answer choices changes. There is a polling tool within this Zoom device or software that we're using. I tried it in the 8 o'clock class and it failed pretty miserably. So I'm going to find out what's going on with that. For right now, we'll just use the chat box to respond. Okay. All right. So let's take a look at what we've got for you here from the textbook regarding the whole process of doing research. Okay. There are 5 steps in doing research about any question you might be curious about. It begins with, well, developing that question. So the question developed here is, Grandma always says, count your blessings. Why? What is the impact of a grateful outlook? How does having a grateful outlook on things affect your functioning? Step 2, develop a hypothesis that might come from an existing theory or something like that. This is your educated guess. So my hypothesis might be that people who think about positive events in their lives will report greater psychological well-being than people who think about negative things. Okay. Design your study. This is probably the most crucial step, right? Design your study and collect your data, right? So in this study, what they do is they randomly assign folks to 3 groups. Group 1 thinks about things they're grateful for. Group 2 thinks about things that are bothersome or annoying. And group 3 writes down any 5 things that happen to them. Analyze the data after you collect them. And what we find here is that group 1 participants are reporting significantly greater well-being than the other groups. So the researchers conclude that people who count their blessings feel better about their life as a whole in terms of psychological well-being. Then you publish those findings. In this case, they go into the Journal of Personality and Social Psychology. You do this right up, and then maybe that study generates new questions. So this study was about psychological well-being. Might this positive outlook on things affect physical health? That might be your next study. Okay, we're going to focus in this morning on this segment here about designing your study and collecting the data, right? The blue slice of the pie, if you will, there, right? Thinking about the different approaches we have at our disposal as research psychologists. When we design our study, what options do we have and what are the pluses and minuses of those options? So the 3 major approaches to research design that you're going to be responsible for are descriptive research, correlational research, and experimental research. So descriptive, correlational, and experimental. These are the approaches that we could take to answering questions that we might have, again, about behavior and mental processes. What I want to point out about these approaches is that generally speaking, as we move down the slide, we have more and more rigor in the study, and ultimately we get down to the bottom with experimental research design, and we finally have the ability to detect cause and effect relationships between and among variables. This is why the experimental research design is often referred to as the gold standard of the research designs, because it can help us detect cause and effect relationships. Now, you might be sitting there saying, well, why is that such a big deal? Why do we want to be able to show that A causes B? Well, that's what science is all about, isn't it, right? Science is an endeavor in which we develop theories that are causal statements about the relationships between variables, right? We think doing A will cause you to do better with respect to B, right? Cause and effect relationships. So if we want to move science along, and theories are statements about causal relationship between variables, we want to be able to detect cause and effect relationships. So as I said earlier, when possible, when it's legal and ethical to do so, the experimental research design should be your go-to approach to your research design. As we're going to talk about a little bit this morning, it's not always possible. It's not always legal, certainly not always ethical to do experimental designs. And I'll give you some examples of situations where, well, you probably can't do that experimentally in just a little bit. We're going to begin the discussion this morning with the descriptive research design. So what's the story here? What I want you guys to be able to do for all 3 of these types of research designs is, number 1, be able to explain what it is. Number two, be able to talk about the advantages and disadvantages of that approach. And number three, probably most importantly for test questions, be able to recognize a description of descriptive and correlational and experimental research designs. If you could do those things well, you're going to be in really good shape when the test rolls around. And probably the best way to make sure you have your head around these three types of research designs is for you to generate your own examples, right? Just think up some scenario and describe how you would approach it in a descriptive research way, or in a correlational research way, or maybe even in an experimental design. So descriptive research, as we start off here, is research in which the researcher cannot control and manipulate the variables that they are observing, okay? So with descriptive research, as the name suggests, we just describe. That's probably the best way to get your head around descriptive research, is we just describe what's going on, okay? We don't manipulate anything. We don't control anything. And then obviously, because we're not manipulating or controlling anything, there's no information whatsoever from this descriptive research design approach about cause and effect. We can't say anything about what's causing what. We're just describing, right? So after test one, I will send you guys an email that will include a distribution of grades for test one. What percentage of students got A's, B's, C's, D's, and F's? That's descriptive research, if you want to even call that research, right? I'm just describing what's going on, okay? If I went over and sat near Hepner Hall today and counted the number of people who walked by wearing SDSU sweatshirts today, that would be descriptive research, okay? I'm just describing what's going on, okay? All the statistics in baseball, batting averages and earned run averages and all that, it's descriptive. It's just describing, right? It's not manipulating. It's not controlling anything. Descriptive research can come in one of three different flavors. It can be in the form of a case study, a naturalistic observation study, or it can come in the form of surveys. And we're going to talk about each of these in turn. Case studies are situations where we take a look at one person and examine their case really, really thoroughly. I'm going to type in here N equals 1, right? N is the notation that we use in science to describe the sample size. So the quote-unquote sample size in a case study is 1. We might study one brain-damaged individual to discover what abilities get knocked out or eliminated when you have brain damage to this specific part of the brain, okay? We might do a case study of an individual who's got incredible memory abilities to describe how they do what they do with memory and to describe the specifics of their memory capacities, okay? Because we have an N of 1, what's the major drawback of case studies? What do you worry about when you do a case study in terms of the findings that you get working with just that one person? They could be an outlier. There's not a variety of different people. So what are you really worried about? Right. I've got a small sample size. So really the issue boils down to one of what we might call generalizability, right? What do you think generalizability means? Well, as Maria just typed in, right, it might not be a representation of the whole population. Does what I found with this one person necessarily apply to everyone? Maybe, maybe not, okay? So the advantage of these case studies is you can be really thorough, really descriptive, and give lots of information about the individual. The drawback is I don't know if what I find with this person has anything to do with, well, like everybody else in the world, right? So that's a major concern. Case studies, though, in psychology have a very interesting history. I wanted to pull in for you for a second here the examples that are in this table from your textbook. So some classic case studies. And we're going to talk at least about the top 3 listed in this table. So next week when we're talking about major parts of the brain, we're going to mention Phineas Gage. He was a railroad worker, as we'll learn in more detail next week, who had an iron rod get blasted through his skull and it damaged his frontal lobes. And from the Phineas Gage story, we learn that those frontal lobes play a really important role in personality, not only in personality, but also in terms of inhibiting impulses. The frontal lobes effectively play the role of the brakes on the car, as I mentioned in passing on Tuesday when I mentioned about the frontal lobes of murderers being less active than those of non-murderers. Gage, according to his doctor, after the accident was no longer Gage, right? He became a really different guy. He would say or do whatever came to mind. He would curse and swear and do socially inappropriate things that he didn't do prior to the accident. So he highlights for us the role that these frontal lobes of the cortex play in your everyday functioning. In the section on memory, we're going to look at the case study of HM. It's a man named Henry Mollison, who for years was just known as HM until he died and they were permitted to tell us what his name was. He was a man who suffered really profound Dory-like memory loss following brain surgery. And I say Dory-like because, like Dory in Finding Nemo, he had an inability to form new memories. And his case study demonstrated for us the role that this structure called the hippocampus plays in memory. And it ended up actually applying and generalizing to lots and lots of people. That effectively what goes on is the hippocampus is the save button that lets you move information from short-term memory into long-term memory. We're going to say more about the hippocampus as we get into the biology section next week. Little Albert we will discuss in the section on learning. I mentioned him briefly the other day when we were talking about Watson and Skinner and the behaviorists. And as we'll talk about there in that section on learning, his case really shows us the ability to use classical conditioning to generate fear responses in human beings. We'll say a lot more about that later on in the course. So these are all case studies that have been really significant in the history of psychology, and it shows you that even with their limitations, case studies have a place in our bag of tricks, if you will, in our toolbox as research psychologists. Second type of descriptive research design is known as naturalistic observation. In naturalistic observation, what we do is we observe the behaviors that we're interested in the real world, okay? So I'm going to just type in here for naturalistic observation. We're in the real world environment, okay? And that can come up in any of a variety of different ways, depending on what kind of psychologist you might be. Let's say we'll pretend for a minute that you're an industrial organizational psychologist and you want to study interaction patterns during staff meetings at some large corporation. Well, to study that and do it in a naturalistic observation way, you go into those boardrooms, into those conference rooms, and you sit and you watch people during those meetings, okay? Instead of creating a fake conference room in your lab at SDSU, you're out in the real world studying those things, those interactions in the real world environment. Maybe you're interested in studying aggressive behavior in kindergarten children. Well, if you're doing that via naturalistic observation, you get permission first, and then you go do observations of kids maybe in the classroom as well as during recess, okay? In the real world. You don't create a fake classroom in your research lab at SDSU, you go out into the real world. If you want to study couples communication, you observe people in their dining room while they're having dinner. If you want to study interaction among single people in bars, you do observations of single people in bars in Pacific Beach. Okay? In all of these cases, obviously there are advantages and disadvantages. The major advantage of naturalistic observation is that you're in the real world. You don't need to argue that what you did in your study is kind of like what happens in the real world because you're there. You're in that company boardroom or conference room. You're in that classroom. You're in that person's dining room. You're in that bar. Okay. What are you sacrificing though? When you go into those environments, what do you give up that you would have if instead you did these studies in your research lab? Ryan got it with one word, right? We sacrifice control. Effectively in your research lab, you can kind of play God, right? You've got your research protocol. You've got a series of things that you're going to do in a specific sequence, and you do it exactly the same way with everybody. In the real world, You've got none of that control. So I'm going to type in here in terms of potential drawback, right, is a lack of control over what's going on in that environment. What's another potential drawback here? When you're sitting there watching those people in the conference room or in their dining room, or you're watching those kids in their classroom, what might happen as a function of the fact that you're sitting there observing those people? Yeah, they might get weirded out. They might feel pressure. They might see you and act differently. Yeah, Alexa's probably got the best little summary there of that, right? So I'm going to type in here, how do I summarize this in a couple words? Act, let me just delete this and move this around. Sorry. I'm going to say here that the act of observing changes what's observed. Now it's going to be all over itself. Whatever. Okay. The fact that you're observing them changes what it is that you're observing. Let me just drag this a little bit here. The act of observing changes what's observed, right? People may behave differently when someone's watching. So you're sitting there in that couple's dining room, and this husband, who's verbally abusive to his wife, calls her names and is really mean every single night, is on his very best behavior, okay? It's really a question of generalizability, right? Is it like what's going on in the real world? Can I generalize from what I observe to what really happens in the real world when I'm not there? So again, pluses and minuses of these naturalistic observation studies. Can be a really useful first step in research for sure, just like case studies can be. The third and final type of descriptive research design is the survey. Surveys involve using questionnaires or interviews, face-to-face, on the telephone, online, about people's behaviors, about people's attitudes, and so forth. Okay? The major advantage of surveys is that we can get lots of data quickly and cheaply, okay? It's a really inexpensive way to collect a lot of data very, very quickly, okay? I use some web-based survey. I make a bunch of phone calls to people using some random number dialer, etc. Okay, I'm asking people about their behaviors, about their attitudes. What's one potential major drawback of surveys? When you ask people, you're getting information right from the source. Info from the source is another advantage. But what might be going on? Yeah, people might lie, right? So let me just scribble that over here, right? People lie. So if you are asking a bunch of ninth graders about their drug and alcohol use or about their sexual behaviors in the past month, they may or may not tell you the truth, right? If you ask people about their attitudes towards different political issues, they may or may not tell you the truth, depending on how they feel about revealing some of those attitudes and beliefs, okay? The other major issue with surveys is that sampling matters, right? The issue is going to be one of generalizability again, right? Sampling matters means it really does matter who you're talking to when you're doing these kinds of surveys, okay? I wouldn't want to generalize from a survey of my Psych 101 students to the overall US population in terms of attitudes about different political or economic issues, okay? Why? Because you guys are not necessarily representative. That's what generalizability boils down to. The representativeness of the people who answered your questions. How are you guys different from the overall US population? Tell me in the chat box. Generally speaking, what's true about you guys versus the overall US population? There's one obvious thing to start with. And Tyra's got it, right? You're younger than the overall population. You guys are more female. This class is typically about 70% female. You're all students. A lot of you are from California, and so on and so forth, right? So that would bring up the issue of the generalizability of my findings. That's why the sampling procedures that you use are really, really important, okay? So at this point, here's what I want you to think about in your mind for a second. Could you generate for me, if I asked you right now, an example of a case study? Just make it up. Could you generate for me, just make it up, an example of a naturalistic observational study, right? Could you generate for me an example of surveys or self-report measures that might be used to, again, in all these cases, to study something that psychologists would be interested in, okay? If you can, that's good retrieval practice from memory, and it's a great way to elaborate on what I've done here regarding descriptive research. I highly recommend that you do that kind of work where it's not just, regurgitating these facts about pluses and minuses of these different approaches or just describing what they are. But if you can generate on your own these examples, that really will show you that you've got a good grasp of what we're talking about. Let me stop there for a second. Any questions about any of these descriptive research studies, these descriptive research design approaches? Make sense? Okay. What do you guys know about correlational research? Tell me something about correlational research that you know already coming in today. Anything that you've heard about correlational designs before? We're looking for relationships between variables. That's perfect. I'm gonna run with that, right? That's what correlational research is really about. It's about relationships between variables, right? Is X associated with Y in some way, right? Is there a connection between these things? And Maria's mentioned that correlation does not mean causation. We're going to get to that for sure. You can't teach correlational research without touching on that. So correlational research in the context of psychology is research that involves looking at connections between things. Are these things associated with each other, right? And as Maria has mentioned, correlation does not mean causation. Does not mean causation. More on that in just a bit. What I want you guys to understand here is that we still do correlational research designs even though they don't illuminate anything about causation, because sometimes we're interested in things that can't be looked at in an experimental research design. What do I mean? What would be an example of this? Well, maybe I'm a developmental psychologist and I'm interested in the long-term effects of child abuse on people's mental health functioning, okay? Well, I think in my mind, okay, if I wanted to show that child abuse causes later mental health problems, I know that I actually have to do an experimental design, right? Because this is the only one down the bottom here that gets me at cause and effect relationships between variables. So, okay, I could design an experiment where I randomly assign kids to be abused or not, and then I could track their mental health functioning over time. Is anybody in their right mind going to let you run that study in an experimental way? No, of course not, right? So does that mean we should just, well, I guess we can't study the effects of child abuse then? No, what it means is we can use correlational designs and do as best we can to eliminate other potential explanations for the outcome of mental health functioning. But we shouldn't just ignore it completely, right? The point I'm trying to make is this, guys. We do correlational research designs, especially in psychology, because there are some variables that we're interested in as psychologists that we can't, won't, or should not manipulate. Think about that for a second. Things that we're curious about that we can't, won't, or should not manipulate, right? So I might think that parents' level of income has an impact on a child's educational attainment in school. How many years of school you complete is related to, or maybe is caused by, how much money your mom and dad have. Well, the experiment would mean randomly assign kids to be rich or poor and see how it turns out, right? Well, we're not going to do that. That's not ethical. But we can look at these things. How much of this income stuff was going on in your life? How much of this education stuff did you attain? And see if there's a connection, if there's a relationship between these two variables. So let's see what I've got for you regarding correlational research with this slide. So as we've already said, correlational research involves measuring whether there's a relationship between two variables. Are these things connected? Like, does attendance at class associate at all? Is it related at all to how well I do in the class? Does showing up matter? Well, I could measure how many clicker points you get for attendance and your course grade and see if there's a correlation. I'm going to tell you that I've done that for years and years and years, and that correlation is going to be about a positive 0.60. I'm giving you a number down the bottom here. And on the next slide, we're going to explain what that number actually means. In such a correlational design, I'm not manipulating anything. Okay? In a true experimental design, I manipulate variables. In a correlational design, I just measure how much of this attendance stuff did you get? How much of this course grade did you get? Is there any connection between those two things? Okay? A correlation coefficient is ultimately computed. The notation we use, like the n for sample size, in this case we use the lowercase r for the correlation coefficient. And that measures the extent to which changes in x are accompanied by either increases or decreases in y. As I get more of this first thing, do I get more or less of that other thing? Okay, so as the number of stressors in my life goes up, does my anxiety level go up or does it go down? What do you guys think? If you had to make a prediction there, as number of stressors goes up, what happens to anxiety level? Probably goes up. Okay, I'm not going to randomly assign you to have a bunch of bad things happen to you or not in an experimental design, but I can look at that via correlational studies, right? How much of this life stress are you experiencing? How much of this anxiety is going on for you? Is there a connection there between those two variables? Okay. What I'm going to give you now on the next slide is some further information about how to interpret a correlation coefficient. So here's my deal with you. I am not going to require you to compute a correlation coefficient. If you become a psychology major and you take statistics, you'll have to do that. That's not my job. My job in intro is to send you on your way understanding what a correlation coefficient is, not even how it's computed, but more importantly, how to interpret it, how to make sense of it. What if it has a positive sign? How is that different from if it has a negative sign? What does the number mean, right? That's my job here in intro in terms of teaching you about correlational research. So let me just clear my scribbling, and we'll use this little infographic from your textbook to explain how to interpret a correlation coefficient. It's infographic 1.4. The correlation coefficient, as it says on the left side here, indicates the strength and the direction of the relationship between two variables. We're going to pull this apart in a second. It always has a numerical value that falls between -1 and +1. It can't be smaller than -1. It can't be bigger than +1. Just mathematically, trust me, that's the way it works. Okay. So if you ever see one that's smaller than -1 or bigger than +1, something's wrong. A zero correlation means that there's no relationship between the two variables. So over here, this third scatter plot, looking at one variable on the x-axis and the second variable on the y-axis, is a zero correlation. There's no discernible pattern, right? As you look at this, like, I don't know what's going on there between those two variables. So a zero correlation is pretty unusual, but it can happen, right? So there's probably a zero correlation between the number of apples that you eat each week and your grade in Psych 101. I'm like, darn, if I had only eaten more apples, or darn, if I had only eaten fewer apples, I would have done a lot better. There's probably no connection at all between those two things. So let's parse now this correlation coefficient number. We've got an example over here, positive 0.73. I can give you some others on this upper left side here. Let me give you 4 different correlation coefficients. We'll start with that positive 0.73. That's a good place to start. So positive 0.73. We'll do one where it's negative 0.19. Do another one, I don't know, positive 0.26. And last one, let's say it's negative 0.88. Cool. Okay, so there's a bunch of different ways that this correlation coefficient might ultimately end up showing up, what we compute. How do we interpret it? Well, we interpret it really in two parts. The two parts are this. Number one, the strength is indicated by the number. And number two, the direction is indicated by the positive or negative sign. Okay, so we've got two parts here. In coming up with our understanding of the correlation coefficient, we need to look at both the sign and the number to be able to interpret exactly what's going on here. So let's talk about strength first. The strength of the correlation coefficient is indicated by the number. Here's the deal, guys. The bigger the number, the stronger the correlation is. Really, really simple. The bigger the number, the stronger the correlation is. Okay? Regardless of the positive or negative sign. So when I teach my students to interpret correlation coefficients, I just tell them to cover over the positive or negative sign. If you're a mathematician, really what we're doing is taking the absolute value of the correlation coefficient. If you're not big on absolute values, that's fine. Your life is still going to be just great. Cover the positive or negative sign and find the biggest number. So let me ask you, with this list we've got over here, these 4 positive and negative correlation coefficients, which one of those is the strongest? Yeah, it's negative 0.88, right? That's the biggest number. Ignoring the positive or negative sign, the bigger the number, again, the stronger the correlation. In psychology, generally the rule of thumb is, 0.1 to 0.3 is like a mild correlation. 0.4 to 0.6 is like a moderate correlation. And, 0.7 and above, we get really excited. I'll tell you, if you want a real-world example from this class, that the correlation between attendance points via the clickers and class grade, basically all the other points other than the clicker points, is about positive 0.60. So that's a moderately strong correlation. What does the positive sign mean? Well, that's the direction. So the direction basically tells me, do these two variables move in the same direction or are they inversely related? Do they move in opposite directions? So for this positive 0.60, what this means is that generally speaking, as you have more and more and more attendance points, what is generally going on with your course grade? Tell me in the chat box. Higher and higher and higher attendance points are associated with increases in course grade. The way that I always do this, guys, is I use my 2 thumbs, right? A positive correlation is when my thumbs point in the same direction. As my attendance points go up, my course grade goes up. Or said another way, as my attendance points go down, my course grade goes down. So positive correlations, they look like this, right? Look at this scatter plot over here. Here's a positive correlation. I think this is like 0.73. It's the one depicted here, right? As I get more and more and more of X, I'm getting more and more and more of Y, okay? For the mathematicians, it turns out that the correlation coefficient is the M. It's the slope of the line that best fits through the scatter plot. In the old Y equals MX plus B formulation, yeah. So you don't need to know that. All you need to know is that a positive correlation is a situation where as X increases, Y increases, or as X decreases, Y decreases. Let me give you some real world examples of things that are positively correlated. And by the way, when you really understand correlations, you'll be able to generate your own examples of positive and negative correlations. There's a positive correlation between your high school GPA and your college GPA. Generally speaking, the higher and higher and higher your high school GPA was, the higher and higher and higher we expect your college GPA to be. Okay? There's a positive correlation between number of years of education that a person has and number of years and your income, right? As you have more and more and more years of education, you tend to have a higher and higher and higher level of income. So yes, Alec, for positive correlations, it's X increases and Y increases, or X decreases and Y decreases, right? So with positive correlations, they move in the same direction, right? So as temperature goes up, thumbs up on my left hand, lemonade sales, especially if it's being sold by iced tea on that commercial, right? They go up. Higher temperatures are associated with higher lemonade sales. Lower temperatures are associated with lower lemonade sales, right? As it gets cold outside, nobody sets up a little lemonade stand on the corner when it's 35 degrees out, okay? So those are positive correlations. Negative correlations mean the variables move in opposite directions. We might say they're inversely related. So as you get more of X, you get less of Y. So if you wanted to talk about, instead of measuring attendance with the clicker points, what if you counted number of absences? As you have more and more and more absences, what goes on with your course grade? Tell me in the chat box. It goes down. So that's a negative correlation, right? More absences, lower course grade. Or if I want to flip it, fewer absences, thumbs down on my left hand, a higher and higher grade, thumbs up on my right hand. Other negative correlations. The number of years of smoking cigarettes and your life expectancy. The more and more and more years you smoke cigarettes, the less and less and less likely you are to be around for a really long time. Okay? Temperature and hot chocolate sales are negatively correlated. Tell me what that means in the chat box. Temperature and hot chocolate sales are negatively correlated. Explain that to me in the chat box. The hotter it is, the fewer sales you have. The lower the temperature is, the more hot chocolate sales. So we had Sam and Juan go in opposite directions there, but they get the idea, and Hillary as well, right? So it seems like you guys have got your head around these ideas related to positive and negative correlation. Let me stop there. Any questions about strength or direction of correlations? Again, the idea is you're going to need to be able to interpret this. How is this different? Because with descriptive research, we were just describing, right? We weren't looking for connections. We were just saying something like 42 people drove by my car today driving in a red car. We're not saying that driving a red car is associated with driving more quickly. If we got to that point, then we'd be talking about correlation coefficient. Is there an association between car color and how fast you drive? I just made that up on the spot. That was actually pretty good. You see the difference there? Yeah, what we're talking about here with correlation research is minimally two, but typically more than two variables, and we're looking how they're connected or how they're associated with each other. All right, now somewhere along the line, I'd be willing to bet a lot of money that you guys were taught that correlation does not mean causation. We are now going to discuss why correlation does not mean causation, and I'm going to give you an example that I've been using for years and years and years because it's memorable and I think it works really well. I'm going to tell you that there is a negative correlation between the number of tattoos that a person has and that person's life expectancy. Okay? What does that mean in English? That means in English that as people have more and more and more tattoos, they tend to have a lower and lower life expectancy. Okay? So more of this is associated with less of, well, being alive for long. One of the reasons that we're going to talk about for why correlation doesn't mean causation is the existence of what are called third variables or confounds. So I'm going to type that in here. Third variables, also known as confounds. These are things that were not part of our measurement in our study that might have an impact on one or both of the things that we did measure. Okay, so if you ran a really poor study and only asked people two questions, number of tattoos you have, and then you actually then track them over time and saw how long they lived, and what you found was that, gosh, the people who had tons of tattoos died really young, right? Negative correlation, more and more and more tattoos, you don't live particularly long. What I'm going to ask you guys for is, in an appropriate way, give me some examples of behaviors that might make it more likely that a person has lots of tattoos and also more likely that that person will die relatively young. What do you think? Criminal activity, being in a gang, yes, associated with having lots of tattoos, and being in a gang is a great way to get dead young. Okay, good. What else? Unclean needles. Let's just go with IV drug use. Okay, probably goes along with having lots of tattoos and probably goes along with not living very long. What else? Risk-taking in general. So somebody in the 8 o'clock section said motorcycle use. If you drive a motorcycle, right, it's probably associated with having more tattoos, and it's also, again, a good way to get dead young, right? So these are all potential third variables that are connected with both having lots of tattoos and not living as long as you might expect to, okay? One of the most memorable moments in my teaching career was probably more than 10 years ago now, when I was doing this example in a research methods class over at USD. And I put up increased number of tattoos associated with decreased life expectancy. I'm up on the whiteboard writing down examples of possible third variables, and the guy, there was actually one guy in the class, there was 19 women and one guy, and the guy just yells out hookers right in the middle of class, okay? Well, that would be just, if you want to summarize all this down the bottom here, you could put it under the rubric of risky behaviors, right? Risky behaviors. You make these choices to do these things, and that puts you at risk of dying younger, and it's associated with increased number of tattoos and so forth, okay? All right. So let's get into the discussion of, again, why correlation doesn't mean causation. And in fact, we are going to talk about the second thing here first. So correlation doesn't mean causation. Somebody probably drilled that into your head somewhere along the line. What we've been talking about is the third variable problem. The correlation between X and Y might be produced by a third unmeasured factor, Z, right? So we might find a positive correlation between the number of churches in a city and the number of crimes in that city. So what could we put in the box here that would be predictive of both having more and more churches and, generally speaking, having more and more crimes? What's the third variable here? More and more churches, more and more crimes. Not necessarily the necessity for repentance. Generally speaking, where you have more churches and you have more crimes, what do you have? Why do we have more churches? More people, thank you, John. It's really simple. It's population size, right? The more and more and more people you have in an area, the more churches you're going to have, and generally speaking, you're going to see more and more crimes, right? They don't do, CSI in a two-person town, right? CSI makes sense for New York or Vegas or Miami, where it's a bigger city. If it's like a two-person town, whoever, was a victim of the crime, the other person did it. Right? So more people are associated with having more churches and also having more crimes. Other examples of third variables. There is a positive correlation between the amount of ice cream sold in a town and the number of drownings that go on in that town. The more and more ice cream that's sold, the more and more people tend to drown. Oh my God, Haagen-Dazs is killing people. No, what is it? What's the third variable that is predictive of both more eating of ice cream and more drowning? It's really, really hot. So they're eating ice cream and they're in swimming pools, and if you're more in swimming pools more often, you have more people have a chance of drowning, right? So you can think of your own examples now of third variable problems, right? So if there's an association between supplemental instruction attendance and improved course grades, if it's just a correlational study and we say, did you go to this and did you do well over there, the third variable might be student engagement. It might be the number of hours that the student is working on the course. It might just be motivation, right? More motivated students both go to SI sessions more often and generally do better in their classes, right? Those are third variable examples that you can start to try to generate on your own. The directionality problem up above here. This is about the fact that we're measuring two variables, okay? And we don't know whether A is causing B or B is causing A. I will tell you, there's a negative correlation between rates of schizophrenia and social class. What does that mean? Well, negative correlation means we have higher rates of schizophrenia. Tell me where and what kind of social classes if they're negatively correlated. In lower social classes. So higher rates in lower social classes. So the question before us then is Is it possible that schizophrenia, which if you don't know involves seeing and hearing things that aren't present, it involves delusions where you believe things that are not true, is it possible that those kinds of symptoms could cause you to end up in a lower social class? Is that possible? Absolutely. Is it possible that living in a really impoverished environment could cause those symptoms to crop up? Is it stressful enough being homeless and jobless and so forth that it, yeah, we don't know which way the arrows go there, right? The only way to disentangle this is to do what? What research design would help you disentangle which way those arrows go? What would you have to do? You have to do an experimental design. Okay, so is anybody going to let you randomly assign people to be really, really rich or really, really poor and then look at how that impacts schizophrenia rates? No, they're not going to let you do that. So we're going to do a correlational design and we're going to make the best of it. Okay, we know we've got the limitation that this is not going to be able to be shown to be causal, but maybe this moves us closer to being able to show that. Okay, if it is legal and ethical to do the manipulation, maybe we begin with a correlational design where we find an association and then we do the experiment, right? So let's talk about violent video games and aggressive behavior. Okay, that's subjected, if it's a correlational research design, that is subjected to the directionality problem, isn't it? It could be that playing violent video games makes you more aggressive. What's also possible? That more aggressive kids seek out those violent video games. That's actually one where we could do an experiment. How could we do an experiment there? We could randomly assign kids to do what? We could have two conditions. Play violent video games or non-violent video games. And then what could we measure? Well, we could measure how aggressive they are, how many fights they get into at school, and so forth. You see the difference there? In the first case, we're looking at these things are connected with each other. In the second case, we're actually actively manipulating something. All right, let me give you one more example so I make sure I drive home this point about how correlation doesn't mean causation because of both the directionality problem and the third variable problem. So let me get rid of my scribbling here. Here's an example that I pulled in for you guys of both of them in action. We find a correlation between low self-esteem and depression. Is it possible that low self-esteem causes depression? Yes. Is it possible that depression causes people to feel bad about themselves? Yes. Is it possible that some third factor like life stress or some kind of biological predisposition or something like that causes both the low self-esteem and the depression? Yes, that's also possible, right? So again, this is why we can't discern causation via these correlational studies, right? Because we're subjected to both problems with directionality and problems with third variables. Okay? Any questions on that at all? We've got about 20 minutes or so to go. What I want to do at this point is jump back to that polling question that I started you guys with this morning and see if you know more now than you knew before. So if a researcher studies the public's attitudes towards capital punishment via a telephone survey, what kind of research design is that? Almost everybody wants to say descriptive. You guys are right. What did you guys say the first time? What did we have a lot of people say the first time? Yeah, we had a ton of people say D. So this is descriptive research. Why? Because we're just describing. We get done and we say 42% of the population is in favor of capital punishment and 58% is against it. I'm just making up the numbers, right? We're just describing something, okay? We're going to do some descriptive research with the clickers on Tuesday in class. We're going to describe like what percentage of the class is freshmen, sophomores, juniors, or seniors. What percentage of the class grew up in San Diego County versus, somewhere else in California versus somewhere else in the U.S. versus somewhere else not in the U.S. We're just going to describe. I'm not saying that those things are correlated with anything else. I'm not manipulating anything. I'm not controlling anything. Okay? It's just descriptive research. All right, let's do another one of these. do a couple of these. I'd like to break up my yammering on with you guys getting a chance to answer some questions. This is directly from an old test. If psychologists discover that people who live at the poverty level have more aggressive children than wealthy people, what would that indicate? How would you interpret that correlation? Uncontrolled research is not even a real term. So we've got descriptive, correlational, and experimental. I'll give you guys a minute to think through this one. All right, 10 more seconds. We're all over the place on this one, right? A's and C's and D's and so forth. All right, the correct answer is C. I want to hear from people who chose C, and I want you guys to explain to me why it's C and maybe why it's not some of the other ones. Because I'd like to approach these questions via process of elimination. So if you got rid of some of the other choices to end up with C, tell me how you got there. More money, less aggressive. So it's a negative correlation, okay? Why is it not A? What is A suggesting? Yeah, so it's not cause and effect. Thomas, do you think A is suggesting cause? Yeah, this is suggesting a cause, isn't it? Poverty has a negative influence, so it's not A. If it's not A, it can't be D, right? Because D says it's all of them. And B says the factors that lead to poverty also cause aggressive behavior. We don't have anything regarding other stuff. We've got what? Poverty level, so less money, thumbs down on my left hand, more aggression, thumbs up on my right hand. They're inversely related. They move in opposite directions. That's just a negative correlation. It's as simple as that, right? It's nothing more than the fact that we've got this negative correlation. Okay? Questions on that at all? Why this is C? Right, and the negative correlation can be interpreted either way, right? Higher levels of income, lower levels of aggression, or lower levels of income, higher levels of aggression. Thanks for that, Matthew. Okay? All right, so let's use our last 15 minutes or so here to get a run into the final of our research designs. We'll go back to our slide here. Experimental research, right? We said right from the get-go, this is the gold standard of the research designs. It is what lets us determine cause and effect relationships. So we are huge fans of experiments if and when we can do them, right? We're not always going to do them, but if and when we can do them, then let's go in this direction. So let's talk about experimental research. It's generally considered the most powerful tool for determining cause and effect relationships. Again, we're worried about cause and effect relationships because we want to test out theories. And theories are statements about causal relationships between variables. This is why we refer to experiments as the gold standard, right, of the research designs. They let us get at those cause and effect relationships. Generally speaking, experiments involve 3 steps. Randomly assigning people to different conditions, manipulating an independent variable, and then measuring the effect of that manipulation on a dependent variable. There are occasions, not always, but sometimes in research where there's actually a step 0, where instead of random assignment, what we're doing is random sampling into our study. Not always, but sometimes we see folks doing random sampling. What does that mean? Well, random sampling looks like this. In the upper left corner, I'm going to draw a little depiction of a study that might unfold this way. We have a big P population. We use some random procedure to draw a little s sample into our study, okay? So we've got about 40 of you guys here approximately logged in, right? Let's say that you're our population. And what I'm going to do is draw in a sample from that population of 40 students. I'm going to do a sample of 20 of you guys. Okay, so this process right here, whereby we go from the population to the sample in our study, that's called random sampling. I'm typing in RS for that. Okay, so when we do random sampling, we pull in people from the population to be in our sample. Okay, once I have those 20 of you out of the 40, let's say, that are here in the live online session today, I can then randomly assign you to one of two different conditions. Okay, I'm going to call those conditions G1 and G2 for group 1 and group 2. Okay, the process whereby I use a random procedure like flipping a coin to divvy you up into those two groups is known as random assignment. So this is where RA is going to be. And again, RA stands for random assignment. So here's the takeaway on this. Random sampling is aimed at making your sample be representative or look like your population. Okay? So if I had all 500 of you in a face-to-face class, 500 is the population, and maybe I sample 80 of you. I do some random generator of your number from, you're listed from 1 to 500 on my roster. I randomly sample 80 of you in. That's to make my sample be similar to my population. So the way I think about this random sampling is it's trying to make your sample be congruent with or similar to your population. Then I've got 80 of you in the face-to-face class now who are in my sample, and I use a random procedure, flipping a coin. Heads, you're in group 1, tails, you're in group 2, and let's say about 40 of you end up in group 1 and about 40 of you end up in group 2. Okay, that's random assignment. And random assignment is trying to make the two groups that are part of your study be similar to each other. Okay, the key thing here is random assignment is aimed at helping us to eliminate confounds. Because what happens is my two groups that are in my study end up being similar in every way. Gender, age, height, incoming SAT score, whatever might matter in my study as a potential third variable. Random assignment does an awesome job of divvying them up evenly between the two groups. And now there's only one difference between the two groups. It's whatever I'm manipulating as my independent variable. So let's say what I do is go back to the sample of you guys, 40 of you here. I draw 20 into my sample and I put about 10 in each of two groups. And let's say what I manipulate here is the use of video during the online session today. For 20 of you, let's pretend, I'm not doing this right now, by the way, but let's pretend that to 20 of you, I send video of me while I'm teaching in this online session. And the other 20 of you, or whatever the hell the numbers were, 10 or 20, one group gets video and one group does not. Okay? And then I measure the effect of this video or no video manipulation on a dependent variable. You guys, help me pick a good dependent variable. How should I test out to see whether you understood what we talked about during class today, either with or without the video? How can we measure the effect of this manipulation? What could I give you? Yeah, I'll give you a quiz. So let's use a quiz and your quiz score as the dependent variable. Here's the idea with the dependent variable, just to keep this straight, right? The quiz score, we think, depends on, that's how I remember dependent variable. We think the quiz score depends on whether you got video or not. And let's assume we think that giving you video will lead to a higher quiz score than not giving you video. That's an experiment. It's actually sounds like it would be a pretty cool one to do, right? It's not illegal. It's not unethical. We're manipulating the use of video. One group gets video, one group doesn't, and we see its impact on your quiz score, right? How well did you understand what it was that I'm teaching you? So in terms of cause and effect language, the way that we think about IVs and DVs is the independent variable is the supposed cause and the dependent variable is the supposed effect, right? using or not using video, we think has an impact on how well you're going to understand what has been taught to you during that class session. Make sense? Let me stop talking for a second. Questions about the general setup here for experimental research designs? You feel like you got it? Just to be clear, I want to go to one more slide, and I'm going to ask you a couple of polling questions before we wrap up. I want to make sure everybody gets the idea behind independent variables and dependent variables. So I've got a slide for you here, right? The independent variable is the variable that I, as the experimenter, manipulate. In cause and effect language, it's the supposed cause. Maybe I'm going to do a study where I look at the effect of texting while driving on your driving performance in a driving simulator. I randomly assign you to one of two groups. In group one, you text while driving, and in group two, you don't. The dependent variable, again, the one that depends on what you got with respect to the independent variable, is going to be measured by the experimenter. It's the supposed effect in cause and effect language. So we might operationalize or make measurable the effect of texting while driving on your driving by counting the number of things that you crash into in the driving simulator. Is that the only way we could measure the impact of texting while driving on how well you're driving? Tell me some other things that we could count, just to make it really simple. What else could we count during your driving? How many times you swerve out of your lane? How often you're speeding over the speed limit? Give me one more example of a dependent variable we could use. How many times you miss a sign? How many times do you go through a stop sign? How often you're braking randomly? How many times people beep at you? These are all great examples. You guys are sharp for coming up with those ways of identifying ways to measure that dependent variable. And Omar wants to count how many people we run over. That's another way to do it, right? So IV, arrow DV, right? So cause and effect, it's texting while driving. We think causes something in terms of how many people you hit, how many stop signs you run, how many times you swerve out of the lane, etc. Okay. We could do an interesting third group in that study, right? If we wanted to make our independent variable have 3 levels, we could have texting, no texting, or maybe talking on the phone. And then we can maybe compare the texting to the talking to see if there's any difference there. Okay, really cool stuff. Ways to manipulate independent variables and look at dependent variables. Any questions on that as we're mapping these terms onto some of these examples? I'm assuming you guys have all heard the terms independent variable and dependent variable before, right? Is that a fair assumption? Okay. I guarantee you I'm asking you a couple questions where you have to identify these. So let's do a little polling question to see if you've got your head around this, and then I'll see if there are any final questions before we're ready to wrap up here. So how about this one? In order to study some effects of alcohol consumption, Dr. Lampard tested the physical coordination skills of 21-year-old men who were first assigned to drink a beverage with either 4, 2, or 0 ounces of alcohol. In this study, the independent variable was what? What was the independent variable? Okay, I see most people are choosing C. Tell me in your own words, why is the amount of alcohol consumed here the independent variable? That's the correct answer. It's the only thing changing 4, 2, and 0. It's the one being manipulated. I like the way Maria said that, right? And Matthew saying it's being controlled by the experimenter. I could use this same question and ask you, what's the dependent variable? So if I ask you that, what's the dependent variable? To be specific, which one is it? It's B, right? The physical coordination skills, because it even says it in the question, right? It says right here, testing the physical coordination skills after drinking 4, 2, or 0 ounces of alcohol. Okay, good. So IVs and DVs. Again, to practice with this stuff, what I suggest that you do, this is what's called elaboration, and it's really a form of retrieval practice as well, is write your own questions, generate your own examples, right? Think back to things that maybe you've read recently. Could even be something from physics or chemistry, right? If I do more of this and I get less of that, oh, that's a negative correlation scenario, right? We're gonna find some of those, and we're gonna use those terms as we go forward, talking about other topics within our course. Okay, we're building the foundation basically here with this research method segment, so that when we get to later sections, we can talk about things like correlations. We can talk about things like reliability and validity that we'll talk about on Tuesday, and we can apply those to discussions about intelligence testing or personality assessment or diagnosing psychological disorders. So we're getting this stuff in place so that when we move along within the course, we'll be ready to tackle those topics that we're going to be interested in looking at. Okay? Let me clear what I've got on here. Any questions about anything that we did today regarding these various research designs? We good? What we've got left to do when we get together on Tuesday, face-to-face, is we've got a little segment where I'm going to look at the different groups that are part of my experimental research design. I'm going to show you an example of an experiment, and I'm going to give you this nice little summary of the advantages and disadvantages of all three of the research designs that we talked about today. Again, descriptive, correlational, experimental. What are the good things about them over here? What are some of the drawbacks to them over here? Okay, that's where we're going to head when we get together on Tuesday. Any final words before we wrap up for today? All right, well, thanks for being here and spending the 75 minutes or so being here live. It makes it more fun for me. It's better when it's interactive. It's not so fun if I just sit here and record things to a blank screen. I appreciate your time today. You can start working certainly on the Learning Curve quizzes for Chapter 1. We will finish up research methods on Tuesday, and that means that those quizzes will be due that following Sunday, whatever that first Sunday there in February is. I can't picture the calendar in my mind right now. Okay? All right, well, I'm going to wrap up the recording. I'll pop out of here. When I pop out of here, that kicks everybody else out. I do have online office hours at 11, so if there's something you need to touch base about, feel free to do that. If not, I'll just see you guys on Tuesday. So have a good weekend, and I'll see you then. Thanks, everybody.